So in this video, we're going to look at two questions. The first one is question 6, which reads, find the equation of the hyperbola that goes through the points, the point 2, 3, and has foci at plus or minus 2, 0. So how do you find a hyperbola if you are given a point where it passes through, and also you are given the two foci? So let's see the solution. So for the hyperbola, we all know that since we are given the foci, it means that we are given the value of c. So c is 2. And so since c is 2, we can use c. So we'll have c squared equation to be a squared plus b squared. So this much, we know also that this is the equation for c squared if you are given the hyperbola. And then what else? We also know that the eccentricity is given by c over a. That's another known equation. Okay. Now, since the eccentricity is given by c over a, it means that we can as well get the eccentricity by bringing the actual c. Since c is given by this, then I can say, oh, c is the square root of a squared plus b squared, like that. Okay, over a. So that if I cross multiply, then now I'm going to have a multiplied by e is equal to the square root of a squared plus b squared. So that if I square here, and I also square on the left, then I'm going to have a squared e squared is equal to a squared plus b squared. So we have this equation there. Okay. Then if we go back to this one, before we also change it there, remember it was directly E is equal to C over A. So if I cross multiply again, I'm getting A times E to be equal to C. Okay, so here, if you wanted again, another way you could arrive at this, if you wanted, you could square the left and square the right hand side. Then you have A squared E squared is equal to C squared, which is what we have here. Because this, getting back to there, you know, at your left, then is equal to C squared. Okay, so now from there, we also know that the equation of the hyperbola, since we have plus or minus 2 and the y is 0, meaning that y is fixed, so it's on the x-axis. So we have x squared over a squared minus y squared over b squared is equal to 1. So what else do we know? Well, we know that this equation passes through, this hyperbola passes through the point 2, 3. So it means that x is 2 when y is 3. So we substitute to have 2 squared, where is x over a squared minus 3 squared over y, over b squared over b squared is equal to 1. We can see what happens now. So we get numbers 4 over a squared minus 9 over b squared is equal to 1. So let's call this equation 1. Where is equation 2? Equation 2 is here. This is c squared. Yeah, this is c squared because 6 over 2 is c. So the a squared, e squared coming from here also if you want. So c squared is equal to a squared plus b squared, but c is given here to be 2. So we have the second equation to be 2 squared is equal to a squared plus b squared. So that we get 4 is equal to a squared plus b squared. Very interesting. Then now, these two equations, we put them together. So equation 1 and equation 2, and then we solve for the variables a and b. And then we'll have our equation. So now how do we solve for those variables from these two equations? So we have a squared plus b squared to be equal to 4. We also have 4 over a squared minus 9 over b squared. 4 over a squared minus 9 over b squared is equal to 1. Is it? Okay, yes. So now here are the two equations. So let's solve them. So if we take b squared the other side, then we're going to have, maybe let me take a squared. So I'm going to have b squared is equal to 4 minus a squared. So that when I come in this equation, I'll substitute now. I'm going to have 4 over a squared minus 9 over 4 minus over 4 minus a squared is equal to 1. So that when we multiply throughout by this guy, 4 minus a squared, here we'll get 4 multiplied by 4 minus a squared minus 9a squared is 1. So when we cross multiply, we're going to have 16 minus 4a squared minus 9a squared is equal to 4a squared minus a to the power 4. Like that. And then we put together now the like terms. So this is going to be a4. When I bring the a4 on the other side, and then minus, that's 8. That's negative 4. So that will be 8 plus 9, which is 17. So I have minus 17 a squared plus 16 is equal to 0. So it's a quadratic. If we let p, or let me use y. I'll use q. If I let q to be equal to a squared, then I'm going to have q squared minus 17q plus 16 is equal to 0. So I have the product here to be 16 and the sum to be negative 17. That means that I can't necessarily use okay, so we can, because those two numbers can both be negative q and negative 16q. Then plus 16 equal to 0. So now I can factorize. Q is common. So we have q minus 1 minus 16. Q minus 1 is 0. And so q is equal to 1 and q is equal to 16. And what is q? Remember, we go back. We said q is equal to a squared. So we have 1. A squared is equal to 1. So that a is plus or minus 1. But anyway, I just want a squared. Yeah, because b has been defined with a squared, so there's no need of going for the whole a. So when I get a squared, so I'll say for this a squared, b squared is equal to 4 minus 1, which is equal to 3. And so I have the equation x squared over 1 minus minus y squared over 3 is equal to 1. Or when q is 16, then I'm going to have a squared should be equal to 16. That means that b squared is going to be 4 minus 16, which is equal to minus 12. Because you know the b squared cannot be minus. Because they need to change the shape of the hyperbola. It's no longer the hyperbola. So when I put a negative on the b squared, then that's going to be positive, so it will be right. And so it means that the equation of the hyperbola that we're looking for is x squared over 1 minus y squared over 3 equal to 1. So this is the setup that we were looking for there. We have found the equation. And if you check, the foci here should be plus or minus 2 if you attempted to sketch this. But remember, it will be a squared plus b squared, which is 4. When you root it, you get plus or minus 2. Okay, then we go to question 7. Question 7. Question 7 is saying, a nuclear cooling tower cross section is a hyperbola. Of diameter 60 meters at the center. Okay. The distance between the two foci is 100 meters. Find the equation of the conic section. So we want to find the equation of the conic section that is arising from this information that is given here. So we are told that it's a hyperbola in nature. And so when you talk of a nuclear, cooling tower's cross section, so you think of it as, so suppose it's this case. So it means if I put, suppose I put the center at 0, 0, then I'll have this distance here. I'll have this parabola inside, and then another one. So now I have a parabola. And then because it's a nuclear tower thing, I can even put, so I can have a good view. Okay, and then this side as well. So now I see that, oh, okay. So I'm dealing with this structure here. So if that is the case, then I'm told that the inside, the diameter is 60 meters at the center. So it means that from here, going here, it will be 30. And then the other side, it will be negative 30. So that I have 60 in total. The four sides are 100 meters apart. So it means from here, for the four side, from here going to the focus is going to be 50. It's going to be 50. And also this side, it will be negative 50. So it means we have this one is giving us C, and this one is giving us A. Okay, so this is the hyperbola. So we know that C squared is given as A squared plus B squared. Now we have C to be 50. When we square it, it will be equal to 30 and then plus B squared. So easily find the value of B. So we have 50 squared minus 30 squared, giving us 16. So B squared is equal to 1600. And as you can see, this is on the x-axis. So let's have x squared over A squared, which is 8 squared. That is 900 minus y squared over B squared, which is 1600, are equal to 1. And we are asked to find the equation of the conic, and here it is found. So what is critical here is just to understand that when they say the diameter at the center, then you check it inside. So you're able to get the value of A. Once I have the value of A, then I also have the value of C. And the only remaining thing to do is to find the value of B. So once you have the value of B, using that formula there, this is for the hyperbola. It's different from the ellipse number. The ellipse would come as A squared minus B squared, because there is an emphasis that A must be greater than B. But here there's no emphasis for the hyperbola. Okay, so hope you find this interesting and of good use. If there are any questions, please, you can forward them here. If there are any questions, you forward them here on WhatsApp. I'll always be there to attend to such questions pertaining anything I do in 2100, the content, whatever I post anyway.